Hvala za predstavitev. Nadaljeval bom pa v angleščini. So this was part of my thesis, and I'm presenting the practical part that with company of Elea we developed. So it is going about moving the BIM model to the analysis, because we, in this time when BIM is becoming very popular and interoperability of the information is very important, because it saves time. It makes a lot of sense to do that and not to model it again, and also all the changes can be then relatively fast implemented also into the calculation. So we try to answer if this is possible and how to do it. So the softwares we're using were Autodesk Civil 3D. We use this because it is the tool for the infrastructure design. It supports DVG file format, which is quite interchangeable. And with the version 2020, they also introduced Dynamo program. This uses visual programming to automate certain tasks. Also, for the analysis, we used Diana. We were testing this software for future use in the company. It allows to import the DVG format, and we saw this as a great opportunity to reduce the risks of transferring the data from one type to another. It uses also descriptive geometry with Boolean functions. This means that you can modify the geometry by, for example, substitution or addition, and uses hybrid mesh for finite elements, and this means that it can mesh the general solids without problems. For the ground data, we use Leapfrog. It's the geological software used in the company. It uses the implicit modeling. It generates the ground information based on boreholes or the surfaces between the different geological structures. But the minus of it is that it uses triangulated geometry, which cannot be imported into the programs for numerical analysis, because the meshing is not really good, or it causes problems, and we had to make some workaround for that. So our initial idea, what I explained, is to use the existing model which was used in Revit and try if we can do that, and also then use the Civil 3D and the ground information, and to combine it somehow. We were also thinking maybe use IFC because it's a standard for data transfer, and move this all into the tool for the numerical analysis. So these were the results. Relatively simple model of excavation resulted in not complete mesh. We kind of expected that, because the numerical analysis requires very, very accurate geometry, and what we produce for the information is not that accurate, because it doesn't need to be that accurate. And on the other side, there was also additional problem that the IFC implemented in the civil doesn't use the arches. So the geometry was already destroyed. So we developed a new version. We were thinking, okay, let's try to simplify the generation of geometry and not redraw it again, because the geometry is quite simple for the calculations. Not so. It doesn't need to use all the. The geometry can be pretty simple. So we use the Excel table where we define the stations of the tunnel. We define the excavation steps and the block name which contains the geometry in the Civil 3D. And on the left side, you can see the polylines or the alignments. It is 3D information. And cross sections that contain the whole excavation geometry and also the lines that define different excavation phases. The next step was to use Dynamo to connect this information and to modify the information and to create the solids you can import to numerical design automatically. Here we define for input data, we tell which line represents the alignment, we tell which tube intersects which tube, or how the excavation progresses, and we also tell if the tube is vertical excavation or horizontal one. And we also point to the Excel sheet. This is how the program then works. First it imports the alignment, then based on this alignment it places the cross sections and makes solids out of them. Then based on the information, cuts the solids to how it is excavated. So it removes the where it is overlapping. In the end, we also then separate the solids into the top heading, bench and invert, and also on the excavation phases. We found out that it has to be done by that, like that, and not like we were used to doing, to place each element separately, because the requirements for the accuracy is very important. For the ground information, we need to change the triangulated geometry to the mathematically defined from Leapfrog. This is also possible to do. You lose some accuracy by that, but it is quite neglected. So on the left side, we see the surfaces that represent borders between different ground data, and on the right, it's the whole the ground that we are interested in, or where the tube is gonna go through. We then import these solids into the Diana and use these Boolean functions I talked about to remove where the tunnel is cutting into the rock. And we use the automatic meshing algorithms to then pretty simply mesh all of it, and then add the information of the excavation timing, and we can run the calculation. Here are some other examples produced with the program, or how it behaves. We can model quite a lot of different geometries. Some small problem is where the two different sizes comes together, because the geometry jumps at that point. We can also model the inner lining basically on the same model, or even anchors with just slight changes to the script. And here are some other practical example, which was then also used for the 2D Deca, and it was tested successfully. The final thoughts, if we talk about speed, we can see that it is faster to produce this geometry than to do it in the program for numerical analysis, because the tools of the BIM are better for generating the geometry than in the programs that are focused on the calculation. The reliability was also quite high. We found some mistakes, but they were pretty obvious, because if didn't mesh if the meshing was unsuccessful, it was not unsuccessful only on one small part, but on all of it. and the automation is not complete. We cannot just create BIM model, use it for data about the progression of our materials, and use it in the numerical analysis, but we are generating the geometry automatically based on relatively few input data that is generated pretty easily. The data transfer from the geological model is not there. We have in geological model the strength of the material, the type of the material. We need to do this still all manually. And if the questions.